Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today, I am going to discuss about a contractual autoencoders. Contractual autoencoder is a specific type of autoencoder used in unsupervised machine learning. An autoencoder is the neural network designed to learn an efficient representation of the input data called as encoding by training the networks to ignore a significant data or noise. This encoding can then be used for a task such as dimensional reduction, feature learning and more. The contractual aspects of CAE comes from the fact that are regularized to be incentives to slight variations in the input data. This is achieved by adding a penalty to the loss function during the training, which shows the model to learn a representation that is robust to small changes or a noise in the input. The penalty is typically the four-sonic norms of the Jobian matrix of the encoder activation with respect to the input and encourage the learned representation to contract around the training data. And we can discuss about the encoder architectures. The contractual autoencoder learns from how your autoencoders consisting of major two components which we call it as an encoder and the decoder. The encoder compresses the input into a lower dimensional representation and the decoder reconstructs the input from this representation. The goal is to reconstruct the output to be as close as possible to the original input. The training process involves maximizing or minimizing the loss function that has two terms. The first term is a reconstruction loss, which measures the difference between the original input and reconstructed output. The second term is a regularization term, which measures the sensitivity of the encoder representations to the input. By penalizing the sensitivity, the CAE learns to produce encoding that do not change much when the input is returned slightly, leading to more robust feature. And the contractual regularizations is all about the basic key features which is used on this contractual applications in the machine learning rather than an artificial intelligence is all about. We can have the feature learnings where a CAE can learns to capture the most salient features in the data which can be used for the various downstream tasks such as classifications or the clustering dimensional reduction. Like other autoencoders, CAE can reduce the dimensionals of data, which is useful for visualizations or the pre-processing steps of other algorithms that perform poorly with the high dimensional data. And the denoising, which use the mathematical formalization for due to a contractual properties, the CAE can be used to remove the noise from the data as they learn to ignore the small variations in the input. The data generalizations, while not their primary applications, autoencoders can generate a new data points by decoding the samples from the learned encoding noise, where we can also train your data sets by the robustness to the noise, designing a CAE or robust to small precreations or the noise in the input data. Improve the generalization. The contractual penalty encourages a model to learn more general features that do not depend on the specific noise or the variation present in the training data. Where we have the stability, the regularization terms helps to stabilize the learning process by preventing the model from the learning tree vitals to the overfitted representations. And the basic challenges, or we can state that the applications of contractual autoencoders where the computational complexity, calculating the Jacobian matrix for the contractual penalty can be computationally expensive and especially for the large neural network. And the hyperparameter tuning, the strength of the contractual penalty is controlled by the hyperparameter that needs to be carefully turned to the balance, the reconstruction loss and the regularization terms. And hence we can also conclude as stating that the contractual autoencoders are the powerful tools in unsupervised learning, providing a way to learn the robust and the stable representations of the data. They are particularly useful when the goal is learn the feature that are invariant to a small changes in the input. While they come with some computational overhead and requires a careful tuning, their ability to improve the generalization makes them a valuable assets in the machine learning practitioner toolkit. I hope you're clear with this contractual encoders. Thank you one and all.